All right, so how are we doing today?
Okay.
Good.
Good, and you?
It's pretty good. We're simplifying rational expressions, and a rational expression is essentially a fraction that has polynomials in it. All right, and this example right here I showed you, that goes back to chapter 1, where we simplified a fraction by taking out a common factor from top to bottom. And so that's the same thing that's going to happen now. Now they ask us a couple of things, and it's important to be able to know this. Find the numbers for which the rational expression is undefined.
Is the chapter
Uh,
6 test you're talking about quiz 4 for us?
no, that's test 3.
Oh, okay, okay. The 097 test 3 spring?
Where are you looking at? Are you looking at it and looking in my math lab, or are you looking at where
Yeah,
at?
I'm in my math lab.
Okay, let me look.
It's math 097 test 3 spring 2021.
That sounds like it, but like I said, I need to go in and look. Somebody else names these things and they send them over. So
Yeah, ours doesn't say like chapter by chapter. It just says like quiz 4.
yeah, see, there's test 1, test 2, which would have been before the final. The final is the third test in a sense, but it's an exam. And then, yeah, you're right, test 3.
Okay, okay.
That matches with this over here. See, with calendar, it does call it test 3. But, I do try to clarify at times that it's on chapter 6. But that's right here, test 3. You're right. But it's
I did
called,
mine last night.
okay, well, good. You're ahead of the game. So I'm starting 7 today because, like I said, as I gave yesterday and today for people to get ready, but we got a lot to cover in chapter 7, so that's why I wanted to get going. All right.
So we're ending at 12 today?
Well, I was going to let people take the test for that last hour. Is what I was planning on doing.
Okay.
But I want to just see how far we get. I want to get through 7.1 at least, because I don't know if you were here when I showed this, but you see, this is today, and it originally just was just the test day and review, and so I changed this around a little bit, because you look at that next week on. Okay, no, that's not as bad as I thought about the 2 days, but I'll probably just move this one up on Monday. So if we get to 7.1, that enough. These things right here, that's real intricate and takes time, but that's Tuesday. I was thinking Monday. But yeah, that's what I'm going to do. And to get people time best. All right. So as I had broken out on this little thing here where it says 1/5. Well, originally I started out with 5/25, and the formal process, most people don't go through all this because they can just take 5, divide it into 25, and get 5 and 1 up at the top. But what you're doing is you're taking out a common factor. Once you take it and factor it into the prime numbers, you take out anything that's common. Well, that's what we're going to be doing here, but I wanted to show you this first because it's important to first find out what makes the rational expression undefined. And that's basically boils down to what makes the denominator 0, because if we have a 0 in the denominator, then we've got a problem because it's going to be an undefined expression. So, in other words, if this x right here were a 5, 5 squared is 25, and then subtracting 25 will give us 0. All right. So the way we're going to handle that is just set that denominator equal to 0 for right now. So x squared minus 25 is equal to 0. Sometimes what I do just to kind of help me keep it straight is I'll put a line through there, because that's what it's not going to be able to be equal to. It's still following the same pattern of solving, but I do that just to show that we can't have it be these numbers. So x plus 5 times x minus 5 is equal to 0, setting each one separately. And then that's x is equal to -5, and on this side it's 5. So what they can't be are -5 and 5, and then they come out with this additional just sentence. It says the numbers that make the denominator under 5 are -5 and 5. I would be just happy if you put x can't be equal to 5, x can't be equal to -5. All right, so that's what it is to make it undefined. That's important. All right. Now, let's take it and factor it in the same way that I did up here, but I'm doing it with this expression here. So x plus 5 in the numerator, and in the denominator, it's x minus 5, x plus 5, because that's that thing we call the difference of squares. Now, going from top to bottom, you can see that this one here and that one there are the same. So it's essentially just like this right here. The only thing left in the numerator is a 1. And in the denominator, it's an x minus 5. Now, the reason why you wanted to deduce first is because once it's simplified like this, you can only see that one instance that makes it 0. In other words, when it's 5, you don't know about the -5 once it's simplified. So that's why you do that before you do the simplification. So this thing simplifies to 1 over x minus 5. All right, any questions? All right. So let's just look at these. All right, up here, this one's a little bit easier than that one that was in the example. First of all, looking down here at that denominator, what would make that 0? What would we put in for x to make it 0? The simplest way, I mean, is just to basically do this. And do that. I mean, if you can see it without having to do this, it's fine, but that means that x the first part of my answer right there. That's this part. Find any number for which the rational expression is undefined. So x can't be equal to -4. Now, to simplify this, what we're going to do is factor anything that's not factored. And in this case, the denominator is already factored. And then up here, this factors as x plus 4, x minus 4. All right. Now, look in numerator to denominator. There's an x plus 4 and x plus 4 here. So that means that's essentially 1 and this is 1. So what I'm left with is just x minus 4 over 1, or just a plain old x minus 4. All right. All right, any questions about that? That's the final simplified form. This is what x can't be. It can't be equal to -4 because it'll make it undefined. Okay, let's say. Here's another one. And again, you can kind of look and see that that's -7, but if you can't see it, you just set it equal to 0. And that means x can't be equal to -7. That's our first answer. That's what makes it undefined. Then up in the numerator, that's x minus 7, x plus 7. And now in the denominator, it's already got it factored in a way, but let's just go ahead and write it out fully. Because that x plus 7 squared just means x plus 7 times x plus 7. And so now those are 1. So I'm only left with what? What's left?
X minus 7, X plus 7.
That's all there is to it. Now, these are what we call rational functions. And if I were to take a graph of this and a graph of this one, they would essentially look the same. All right. It's just that the difference is that the original one has certain restrictions on that denominator. Let's see something. See if I can help. And these are kind of all right. I'll just kind of show you here on that graphing thing I got. Just for visualization. I'm going to graph this full thing here. Now you don't have to worry about graphing these. I'm just doing this for a visual. Whoops. All right. So you can kind of see that right there is just a line, even though it looks, fancier than that. It's just a line. All right. Now I'm going to put dot here. Whoops. Anyway, well, I'll just go ahead. And the other one was x plus 4. Oops. What was it? It was x minus x plus 4. Oh, x minus 4. You can see when I graph it, it's pretty much the same thing. The only thing that's different is that at that dot right there, that would be where it's undefined at. And that's why it's important to be able to do this beforehand, determine what's undefined, because when you simplify it down, you can't see because there is no denominator in this case, or some of the denominators gone. So anyway, that's just to visualize and show you. It's the exact same thing once you simplify it. It's just that you need to identify those undefined values first. All right, why don't y'all take a shot at this one, and then I'll give you a minute, and then we'll go through it. Factor that. See what happens when you factor that. Because it really helps to factor the whole thing first. Then you can look for the undefined values. Remember, this is that same old thing that keeps popping up, the difference in squares. So that's the denominator. What about the numerator? What does that factor out to be? I'm going to do the undefined part here. So set them equal to 0, and then this solve. So a can't be equal to 5. A can't be equal to -5. All right, what does that numerator factor as? Up there, there's the only thing that's we can take out is a common factor of 5a. And then once we factor it, that's what we got left. All right. So what's alike top to bottom? Well, there's an a plus 5 and an a plus 5 that turn into just a 1. And so here's the simplified form. And here's what it can't be equal to. That's what makes the expression undefined. And you see the problem and why we need to do it before we simplify it is because if you just have the one that I have circled there, you don't know about the -5. You only can see it here as just the regular +5. So that's why before you simplify it, look for the values that make it undefined. All right, any questions? All right, well, let's jump on down here. All right, now some of these are going to be harder to factor than others. Some of them we might have to go over to the board on and do, but that's what I said about factoring. Factoring is the key skill to bring away from this class here, because it's the most widely used things or tools in mathematics. So up here, It's just an x plus and an x minus. And this is just my 2 cents worth on this. So rather than having to think those through, let me just kind of give you a little push in the right direction. Always factor the easiest thing first, because especially on these like homework type problems, and they're generally going to have the same factors because they're designed to have the same ones top to bottom so that you can take something out. So the denominator in there is really the easiest one because it's just the greatest common factor. And that greatest common factor is 3x. And so that's going to be 3x plus 9. Now, you know what I'm looking for up here now? I'm looking for, I'm sorry, you know, I messed this up. It's supposed to be x plus 9. So it's 3x, and then it's an x plus 9. I said x plus 9, and then I wrote the 3x. So that's the denominator factor. Now I'm thinking, okay, one of these is going to be 9. And you know what? Look, 9 goes into 36 4 times. So you can take the easiest one and factor it, and that'll give you a hint on how to factor some of the larger ones, or the ones you may not necessarily want to go through. All right. And so before we move on about the numbers, x can't be equal to 0, because if x is 0, 3 times 0 is 0, and 0 times whatever this is 0. And it also can't be negative 9. All right. So there's the two things we want to know, that and this. Simplified, this is what makes it undefined. All right. Now this one's going to be a little bit of a tough one. I'm gonna probably just have to go over to that other board. And if you didn't see this, I had a came in late. That's what we're dealing with today. I'm getting this a little bit of chapter 7 in, and then I'm going to conclude and give you that time to take that test. Okay. So I know some people already take it, and some people might want to wait, but remember, if you wait, you just realize anything could go wrong, right? The internet could go down until right last minute. Anyway, let's see. I was going to go and see if I could find I may already have this. Maybe that's not it. Oh, there it is. All right, we already looked at 4. So let's look at 5 and 6. All right, and this gives us more room to do it, because sometimes that little space they give us on the sheet. All right, what was the other one? Oh, okay. These aren't so bad. I don't know why they put the harder ones right in the middle. All right, now these, I mean, it's just a matter of using that AC method, I'm going to use do the denominator one first, just because I think that'll be the easiest one. So A times C is equal to 6 times 1, which is just going to be 6. So the factors of 6, and they both have to be the same sign, that add up to 5. So that's 2 and 3. So what I can do is, well, I tell you what, I'm just going to do it over here, and then I'm going to write it up there. So I'm just going to do the side work here. So this is 3x. Oh, this is negative. I'm sorry. That's negative 2x. So negative. Oh, and I got a eraser on this one. So sometimes the factoring is just going to be just as long as it is, but you shouldn't have to do it on every one of them. Like I said, you can use these as hints. All right. So then this is going to be down here at the bottom. It's going to be 2x minus 1. All right. Now let's kind of use that as a hint and see if it can help us factor that one up there. All right. I think if we use, well, either one of these might go in there. Let's see. I may have to just go through the whole process because I'm kind of hitting a blank wall here. 3x minus 1. Hold on a second. Scribbles in here. I don't want to room up. All right, let me see. So one of those going in there. I'm just going to see if I can figure it out here without having to write it up there. And like I said, you're always free to go ahead and factor it the long way if you can't see it. Yeah, this is the one that's up there. It's 2x minus 1 and then 3x plus 2. And like I said, you could go through the whole process like this and figure it out. But it would have been quicker to do it that way. But I was just dividing each one of these in there and see which one worked. And it was this one. So again, we got to determine the values that make it undefined. So let's do that over here. So x can't be equal to 1/2. Can't be equal to 1/2. And then it's also going to be 1/3. If you solve that. It's 1/3. So there's the two values that it can't be. If you put those in there for either one, you'll get a 0. And then here's the simplified version here. So there's the simplified. Now, on this number 6, we did one like this in factoring, and I think it started with like, it was written backwards. Like, in other words, the x squared was last and the x squared term was negative. And I had mentioned to you that if you factor out a -1, it makes it kind of normal. Well, that's what's going to happen here. First of all, it's already factored in the denominator. So we know that x minus y minus 7 cannot be equal to 0. So that means y can't be equal to 7. So that's what makes it undefined. Now, up here, we're going to take this and simplify it. Like I said, down in the denominator, it's y minus 1. Now this one is backwards. In other words, the y squared term is negative. Now, believe it or not, you can still factor it, but here's a little bit of a crazy issue. It factors as this: 7 minus y and 7 plus y, by the same principle as the difference of squares. But here's the thing, and I'd like to see somebody chime in about this. Is there anything that we can simplify now? Is there anything that we can divide out? In other words, are there any common terms top to bottom? Now, if the denominator was a y plus 7, then these two could come out because 7 plus y is the same as y plus 7. But with this, and I'll just put it down here, these two things are not exactly alike. All right. So how can we fix that? Well, it's a matter of a factor of -1. I can do it with either top or bottom. I'm going to do it in the bottom. And take out -1 down there. So I'm going to take a factor out of -1. And that's going to make it -y plus 7. All right. Which, if I turn it around, that's -7 minus y. All I'm doing now is just flipping those things, see? Turning them around there. Now, those two things are exactly alike. And what I've got is a factor of -1 down there. So what I got is 7 plus y over -1, or you can just write it as -7 plus y. So this is the kind of factoring that we looked at briefly in chapter 6, but you can always factor out a -1 out of anything. But in this case, it just helps us do that. And so that denominator, the terms get turned around. So this is the simplified version of it. It could also be written like this if you wanted to. Either one of those is the same. And then it's undefined for y is equal to 7. Y cannot be equal to 7. All right. All right. All right, let's go back to the other board. All right, so let's just get back to business here now. As I had said is, look at your easiest thing and see if that helps you in factoring. In other words, this right up here is already factored, this x minus 3. Now, negative 3 goes into 9, negative 3 times, and negative 3 gives you negative 6. So that denominator is actually x minus 3 times x minus 3. All right. So we only need to worry about the one thing because they're both the same, but so this can't be equal to 0. So that means x can't be equal to 3. And you can kind of verify it. If you put a 3 there, 3 minus 3 is 0. So 0 times out would be 0. Even if you put it up here, 3 squared is 9. And 9 and 9 is 18. And then 3 times negative 6 is negative 18. So that would give you 0 there as well. So we don't want to have 3 down there. And then this is the factored form. We can just take any ones out we want. So that's just going to be a 1. Take one of those out. So this is 1 over x minus 3 as your factored form of it, or your most simplified form of it. Okay. All right, now these actually are easier to factor in my opinion. I don't know why they didn't put 7, 8, and 9 in the second row, because these were the hardest ones. All right, so let's see. So we can just take that, set it equal to 0. Find out where it's, let's see, so that's 4x. It can't be equal to 8. So x can't be equal to 2. No 2. Because look at this. If you got a 2 for x, 2 times 4 is 8. 8 minus 8 is 0. So it cannot be an 8. I mean, sorry, a 2. Because then that'll give you a 0 down there. All right, so let's factor this whole thing. The bottom is probably the easiest one to factor by factoring out a greatest common factor of 4. And then you got an x minus 2. Now up here, there's a greatest common factor as well. Now, unlike the denominator, the numerator can still be factored one more step. And you know what? It's going to be the x minus 2, x plus 2. Like I said, you can use this as a hint right there. All right, and then down here, we got x minus 2. So now that we know what the denominator can't be equal to, we can just strike out the ones. And I don't think we're finished yet because look at this. You got 2. You got a 4 down there. So 2 goes into 4 twice and into itself once. So this is just x plus 2 over 2. All right, any questions? I mean, like I said, as we're using our factoring skills now on these rational expressions, which just means they're fractions that contain polynomials. All right, so here, last one. Only thing I see is a GCF. We can do the denominator first just to make sure. We can wait till it's factored, but I don't see too much benefit in that. So this is 4x can't be equal to 16, which means x can't be equal to 4. And you can just look at it and see here. 4 times 4 is 16. 16 minus 16 is 0. So we don't ever want a solution to be that. And when we get to equations later on in this chapter, that's something you got to be mindful of. You got to be able to know what makes it undefined. So if you come up with a solution that is one of those unidentified values, it has to be thrown out. So anyway, let's simplify this. GCF. And I don't think anything's going to change here. It's just x. There's nothing that can be simplified on this one. Double check that for me, make sure. Because it's not seen straight today. All right, so make sure we had enough time. And see, you can see throughout, factoring is going to play a part in here. So that's why factoring is key.
Excuse me, can you go back up so I could write?
Well, you do know these are being recorded, huh?
Oh, okay.
Well,
Okay,
that's there, all right? Because, I mean, I'm not saying for people never to write stuff down, but that's the one area where writing stuff down is not important, is in math, in my opinion. You know, the way I do it is a whole different process. Like I said, if you want to see the process, you can go back to the video. But the more important thing is just following the process. Do I understand how are we getting from point A to point B? But that can't be simplified, right? Nothing common. So it just stays like that or like this. All right, if you get any questions, let me know. I'm going to stay here for a while. You work on your test if you need to. I'm giving you that time to do it. And then, like I said, next week we're going to go fast and loose with chapter 7. Chapter 7 is just basically all using the factoring now to simplify, because when you start dealing with fractions in chapter 2, that's why they have the information about factoring, because that's how you reduce fractions. But anyway, you can just see, like in this, about multiplication. And this is multiplication and division. If you got everything factored, oftentimes it makes things really easy to do, because you can just take out all your common factors and there's really no multiplication left to do for the most part. And of course, just like with old multiplication division here is also defined by multiplication by the reciprocal. All right, so that's what we'll take up next time. But if you got any questions, feel free. I mean, it doesn't have to be about chapter 7. I mean, I'm open to chapter 6 stuff too, since we are still officially dealing with that.
Okay, we I'm sorry, I'm not feeling good myself. Are we going you want us to go to the med lab now and finish the test and everything?
Yeah, where you take it at? Yeah. I'm
Wait,
just giving
so
you that
say that
time right
again?
now. I'm giving you that time, yes, in order to take it. So like I said, it's time to do it. Some people have already taken it, so but I'm giving you time so there's no excuse for it, you know? Use this time.
Okay. Mm,
But yeah, the test over in my math lab. Every all the materials over there for the most part.